To be able to use the trigonometric functions with both positive and negative angle inputs, it can be helpful to use the concept of even and odd functions. So let's take a look at that. Now you may have seen the definition of an even function and an odd function in a previous class. So hopefully this is a reminder. A function is called an even function if for every input x, f of x is equal to f of negative x. Even functions are symmetric about the y-axis. A function is called an odd function if for every input x, f of x is equal to negative f of negative x, or similarly, negative f of x is equal to f of negative x. And odd functions are symmetric about the origin. So let's begin by recalling some values on the unit circle. Let's say 30 degrees in this image. So it's not marked as 30 degrees, but it looks like it might be around 30 degrees. So if we were to start on our positive x-axis going counterclockwise, that angle in the first quadrant looks like it's 30 degrees. So we could say that the cosine of that 30-degree angle is equal to, do you remember what that is? The cosine is the horizontal, right? And so that's going to equal the square root of 3 over 2. Now, what about the cosine of negative 30 degrees? Well, the cosine of negative 30 degrees is starting in the same location, but now we're going clockwise. So cosine, remember, is the x value. So notice in this image that even though we are in different quadrants, that the x value has remained the same. So the cosine of negative 30 degrees is actually equal to the same thing as the cosine of positive 30 degrees. Therefore, we can say that if you have the cosine of an angle, we're just going to randomly call that angle t, it's going to have an output of x. If that input is negative t, that we're still going to have an output of x. And so therefore, that matches with what we called the even function that I hoped was a reminder for you. So the cosine is an even function. Now, what about sine? Let's just think about that for a second. Let's just go ahead and use that 30-degree angle again. So if I were to say the sine of 30 degrees, the sine, of course, is that y value, and that's going to equal 1/2. Now, if I do the sine of negative 30 degrees, of course, I am in that fourth quadrant, so it's still going to have the same absolute value, but it's going to actually be negative 1/2. That is the same thing as the odd function definition that we see above. So what's happening is we have the opposite, right? We have the opposite inputs and we have the opposite outputs. That's exactly what's happening here. If we have a positive x and a negative x as our inputs, so they're the opposites, then one output is going to be negative and one output is going to be positive. So they're the opposites. So we can say that the sine function is an odd function. So in summary, an even function is one in which f of negative x is equal to f of x, and an odd function is one in which f of x is equal to negative f of negative x, or the way that we saw it, f of negative x equals negative f of x. Now, the cosine and the secant are both going to be even. We convinced ourselves that the cosine was even. Why do you think the secant is also even? Well, the answer is because cosine and secant are reciprocal functions. So secant is made up of the cosine function. So they're both even functions. The sine function, we said, was an odd function. The sine function is an odd function. And because there's a relationship between the sine, the tangent, the cosecant, and the cotangent, those all have sine values in them, those are all going to be odd functions. All right, so let's take a look at an example. Part A says, find the cosine of negative 30 degrees. All right, so the cosine of negative 30 degrees, it's an even function, so that's going to be the same thing as the cosine of positive 30 degrees. And we know that the cosine of positive 30 degrees is the square root of 3 over 2. Part B, the sine of negative 420 degrees. The sine of negative 420 degrees is going to be the opposite, the negative version of the sine of positive 420 degrees. Now, do we know what the sine of positive 420 degrees is? Well, let's see. I think 420 degrees would represent one whole rotation around the circle, wouldn't it? So 360 degrees plus another 60 degrees, and we know that the sine of 60 degrees is square root of 3 over 2, and so this is going to be negative square root of 3 over 2 as an answer. The next question here says, if the cotangent of t is equal to the square root of 3, then what is the cotangent of negative t? All right, so the cotangent of negative t, it's an odd function, so that's going to equal negative cotangent of t. And we were given that the cotangent of t is equal to the square root of 3, so by substitution, this should be negative square root of 3. Now, do you have to use even and odd properties? In other words, could I have just, let's look at part A, could I have just gone to negative 30 degrees on the circle and identified what the cosine was? Yes, you could. For the sine of negative 420 degrees, could I have just gone to negative 420 degrees on a circle and identified the sine? Yes, you could. However, most people seem to find working with positive angles a little bit more intuitive than working with negative angles. And so I would suggest that you give this a try, where you're basically always going to rewrite negative angles as positive angles using this even and odd property idea.